Before we do this next example, it's probably a good idea to make sure you're familiar with two common banking formulas that you used in Algebra 2. A is going to be our amount at the end. Sometimes people write A of t. It means the same thing. All right, A or A of t equals. Well, if we're going to compound interest continuously implies that we're going to use Euler's number. Euler is spelled like this. Leonhard Euler, mathematician. Euler's number, he of course named after himself, E, 2.718, blah blah blah. It is an irrational number, and we use this special number as a kind of like a growth factor to determine this rate at which things grow when they grow continuously. All right. I have in my playlist, I may have saved it, but I love this one video Eddie Wu does on WooTube where he explains where E comes from. I think he does a great job and he has a great accent, so totally fun to watch. But this formula will be P times E raised to the RT. And a lot of people will be like, oh, per. Sure, you can call it per if you want to, but make sure the R and the T are the exponents of the E. You don't multiply the P and the E first. You maybe can multiply R and T, then raise E to that power, and then plug in P and multiply that. But P is the principal or initial amount. E is Euler's number. It's a button on your calculator. R is your rate as a decimal. While this rate is a decimal, it's still the rate as a percent. So you would move the decimal twice because percent means per 100. So you would have 0.0275 is the number you'll use, and T is time. Typically, these problems are set up so it's time in years, and then that goes with that. And if we compound our interest, compounded n times per year, compounded n times per year. I mean, you could change it from years to something else, but normally we write it like this. And that's going to be A equals P times the quantity of 1 plus R over N raised to the NT. Okay? Now, what do we have there that's different? R is the same thing. N is just the number of times per year, and T is still time. Alright, so we have that equation for us too, or formula for us as well. So how many years will it take? So you're solving. As soon as you read these word problems, how many years? Well, that tells me that I'm trying to solve for time, so I should be using a formula that has a t in it, and everything should be filled in except for t if I'm solving this, right? Will it take to grow? So your money is increasing, it's getting larger. Grow $4,000 to $6,700 if it is invested at 2.75. So what else does that tell me? My rate is 0.0275. That means my starting value or principal was 4,000. That means that my amount at the end will end up being 6,700. Well, looks like I got a lot of stuff filled in over here if it's compounded continuously. Okay, so if it's compounded continuously, we are using A equals P times E to the RT. A is going to be 6,700. P is going to be 4,000. E is just E, Euler's number. RT is 0.0275. How long will it take? Well, that's what we're looking for, so T. Okay, if you recall, we're solving for an exponent. It'd be amazing if we could use one-to-one property. We really won't be able to, but that's fine. You got to get this part alone first, okay, before we can do anything. So the 4,000 is attached with multiplication. I'm going to divide both sides of my equation by 4,000. Where does that get me next? Well, the zeros cross out essentially. I'm going to write 67 over 40. I don't have a calculator, so I'm going to do this without a calculator. And if you want the exact, well, it'll be exact. If you want the approximate value as a decimal, then you're going to have to use a calculator. E to the 0.0275 t. Okay, now to solve, I mentioned in another video where we were dealing with exponents that log is normally used for something like that. Here I need it, there I didn't need it. What kind of log is the inverse of e? The natural log, which is ln, because in Latin your adjective comes after your noun, so log natural. That makes sense hopefully to you. If we take the natural log of both sides, you're not multiplying by natural log. You don't multiply by a square root, you take a square root. You take a limit, you take the sign of something. So we're going to take the natural log of both sides. Since these are inverses, it's like having something right here. We did times 4,000 and then we divided by 4,000. And what happened? Boom, it reduced out. They got rid of each other because multiplying and dividing by 4,000 are inverse operations. What happens here is the ln and e disappear. They're inverse operations. This really came out front. Okay, again, there's much more to this, but if you're reviewing or if you just really need to know how to do it and how to get the answer, what happens next is you get 0.0275t, okay? For further lessons, you need a separate video, okay? That's not what this is for. So then this is the ln of 67 over 40. Now, it's important that it's typed or written the way I'm kind of showing you right here, okay? Next step, I need to get t alone. So I need to divide. Oh boy, I'm totally cut off and didn't see. I'm so sorry. I need to divide both sides. So I'm going to write the division twice this time by 0.0275. 0.0275. So anything over itself is 1. That's gone. I'm left with a t on the right side. I'm just writing it on the left. In your calculator, you are going to have a numerator and a denominator. This is the 0.0275 in my denominator. Maybe you put parentheses, depends what your calculator settings look like. And then in here, you're going to have the ln of, you definitely need these parentheses, okay? The ln of 67 over 40, division is over, division is your fraction bar, okay? You might want to even just do the ln of 67 over 40, hit enter. Make sure you close that parenthesis, hit enter. Get that number. Don't retype it around and then divide by this number. Hit enter. And that's going to give you your answer. Now, what would be different if this problem asked you to do this monthly instead of continuously? So, it'd be a little different in the sense that we're going to use a different formula. 6,700 is going to equal 4,000 times 1 plus 0.0275 over n times per year. Monthly means 12. Raised to the nt, so that'll be 12t. Again, I'm going to divide both sides by 4,000. So what does that give me? I'm still going to write 67 over 40. I don't have a calculator. That's great, okay? Now this, you could, again, do it in a calculator. Divide that first and then add 1 to it. You're going to get 1 point something, okay? I'm going to leave it like this because I don't have a calculator, so I don't want to make up numbers. Alright, next. I need to take log of both sides. If I use the ln button, say you really like natural log, that's fine. I'll have ln of 67 over 40 equals. Now, when you have the ln of whatever that number ends up being, 1 plus 0.0275 over 12, anytime we take the log of something raised to a power, you might remember from algebra, you should remember, that your exponent can come out front. So this will be a 12t out front. And really the 12 is also being multiplied. If I want to get t alone, all you have to do is divide by 12 and whatever that is, the ln of point whatever. So t will be alone. T will be on the right side. I'm going to write it here. That will be my numerator, which is the ln of 67 over 40 over my 12 times the ln of whatever that big mess made over 12. Now the big thing here, if you type this, divide by 12 times, and don't put parentheses here, depending on your calculator, it might divide by this first, depending where it pops up on your screen, if you have pretty print, and then multiply by this up top. If you want this in the bottom, it needs parentheses. So this will give you the answer if the question were to compound the interest monthly, and then this will give you your answer if we were compounding the interest continuously.